This is the video for lesson number 11, solving equations with the distributive property. Our objective for this lesson. At the end of this lesson, you will be able to apply the distributive property when possible when solving equations. You will continue looking for combining like terms and using properties of equality. So let's jump right into example 1. I will explain as we go on what those lines are for. So we need to solve. Notice this looks a little bit different than the ones that we have been doing in class. However, it should look familiar from a previous topic. There are parentheses here, and there is a 5 outside the parentheses. Do you know what we need to do with that 5? If you guess distribute it, you are correct. So we are going to distribute the 5 to both terms that are inside the parentheses, remembering that we really multiply when we distribute. Our new equation is 10 plus 20x equals 85. Now I've given you these lines over here because I'd like you to justify what you did to get from the given equation to your new equivalent equation. For example, we use the distributive property. So I'm going to write that on this line and go ahead and write it on your page as well. Next, you're going to see if you can combine any like terms on the same side. I see a 10 and a 20x. Those are not like terms, so I cannot combine them. Now let's put a box around the x, and let's begin isolating the variable. Notice the 10 is the least connected to the x, or it's the constant, so we must get rid of it first. It is positive, so I will subtract 10 from both sides of my equal sign to get it to go away. We're left with 20x equals negative 70, it's positive 75. On the line to the right, think about what we did to both sides. We subtracted 10. But if you remember from the lesson from the other day, we talked about there really only being two types of properties of equality. Remember that subtracting 10 is really the same thing as adding a negative 10. So the property that we have used here to get our new equation is the addition property of equality. I'm just going to abbreviate here since I'm running out of room. Like that. Lastly, we have 20 times x equals 75. I need to get the x alone. To undo multiplication, I'm going to divide by 20. Now, if you're going to divide 75 by 20, you're going to notice that you get a decimal. So you can write your answer as a decimal, or you can write it as a fraction in simplest form. So I'm going to write x equals, and since I love fractions, I'm going to keep it as a fraction in simplest form. I know that both of these numbers, 75 and 20, are divisible by 5. So 5 goes into 75 15 times, and 5 can go into 20 4 times. Or, like I mentioned, you may write your answer as a decimal. In this case, it is 3 7/75. Let's fill out that last line thinking about the other property that we have done. So the last step was dividing by 20. Remember, there's only two properties of equality, addition and multiplication. Dividing by 20 is the same thing as multiplying by 1 over 20. So we will justify this by saying that we used the multiplication property of equality. Okay, when you're ready, go to example 2. Okay, so I notice here that there are parentheses, so I must get rid of them just like I saw before. Remember that we use the distributive property. My new equation is going to become n plus 5n minus 5 equals 7. And we use the distributive property. Now this time, I notice that I have an n in that appears more than once. I see a positive 1n and a positive 5n. So I'm going to use my steps that I've been using in class, and we can combine these into a 6n. On the line, we will justify this step by saying that we combined like terms. Next, I'm going to add 5 to both sides. I will justify that by saying that we used the addition property of equality. And my last step is that I need to divide by 6. Remember that dividing is really multiplying. In this case, dividing by 6 is the same as multiplying by 1/6. So we really use the multiplication property of equality. And we get that n is equal to 2. Okay, so this is it pretty much for lesson 11, so let's sum it up down below. So I want you to think, what do we need to look out for now when solving equations? Think about what we just did in those 2 examples above for our first move. From now on, the steps that we are going to look out for when solving equations will be as follows. The first thing you're going to look for, that one's not supposed to come up. Is distribute when possible. Okay, please copy that down. Remember, distributing will be possible when you see a set of parentheses. After you do that, continue looking for combining like terms on the same side, if possible. And the last step, use your properties of equality. All of these steps will get you to solve for the variable that is given. When you're ready, please turn the page to example number 3. Okay, for this one, some of you might be ready to go on your own and try it, or you can follow along. So I notice that there are parentheses. I want to get rid of them. The only way to get them to disappear is to distribute. In this case, a positive 3. 3 times 2x gives me 6x, and a 3 times a negative 6 is negative 18, and I bring down equals 18. I identify my variable, and I want to isolate it. We always eliminate or get rid of the constant first, or the number that is least connected to the variable, in this case the negative 18. I will add 18 to both sides to get rid of it over here. My new equation is now 6x equals 36. Lastly, I notice that it says 6 times x. To undo multiplication, we do division by that same number, that same coefficient, to get it to equal 1x. Do it on the other side. In this example, x is equal to 6. Now you do have plenty of room for number 3, so I'm going to ask that you do a check below. So please pause the video, do your check, rewrite the equation, plug in 6, and make sure that you get a true statement in the end. Number 4. I see that I can distribute the 12 on the right-hand side. I'm going to distribute it. I get 36 minus 12x. I don't see any like terms on the same side, so I can't do step 2 from my notes. And then I will begin isolating the variable. In this example, I'm going to subtract 36 to get it to go away. Since 36 is positive here, minusing 36 will give me 0. On the left, 60 minus 36 is 24. And I'm left with over here a negative 12x. Be careful and make sure that you attach that negative sign that belongs to the 12x. Lastly, I'm going to divide by negative 12 to end up with positive 1x, or just x, and x equals negative 2. You can keep your answer just like this. You should have room below again, so I'm going to ask that you do a check. I will be checking this tomorrow to make sure that you followed along and completed your checks for both questions. Go ahead. The last one, number 5, I'm going to ask for this one that you try this one on your own. Pause the video. When you are done, please hit play and all of my work will pop up. So please hit pause and do not hit play until you have tried it on your own. Go ahead. So for number 5, the final answer for B, the solution, is that B is equal to negative 1/2. If you got that correct, great work, awesome job. If not, please take a look at my work and see where you may have made an error and fix it. I'd just like to point out at the end here, when you divide by 12, a negative divided by a positive is a negative. That's why my answer is negative. But keep in mind that this says 6 divided by 12, which really simplifies to 1/2. So going forward, please don't be afraid if you get answers that are fractions or decimals, basically numbers that are not whole numbers. Your answer can be anything. So great work. Please bring in this worksheet tomorrow to class and be ready for more practice. Thank you.